Logi 2, okay, those are the different names. But what it means,
The ability to detect two objects, one in front of the other.
What she said.
that means the sound is going in this direction. And we change the question for you. These are two structures. These are two structures. This is, say, 2.5 millimeters apart. This is only 1 millimeter apart. Which of these is hardest to demonstrate as an individual structure?
1 millimeter apart.
This one is hardest, and this one is the easiest, right? And a little more, assuming this is,
This one's harder to demonstrate.
assuming this is 2 millimeters apart here. What's the minimum SPL to demonstrate that as an individual structure?
0.1. 1.
Think first, look at your numbers, look at your formula. If it is between this and this structure is 2 millimeters, what will be the minimum SPL to demonstrate those two as a separate structures? You say 1. Any other number?
0.1.
0.1 what? Seconds,
Millimeters.
kilohertz, millimeters.
To demonstrate, sorry, I'm writing it down.
As to
Two separate structures.
Well, the formula is number of cycles
Okay.
times lambda, the wavelength. So the wavelength in this one is
Well,
gonna be smaller than the other one.
But we're talking about like acting over
yes, would be SPL divided by
2.
Okay, it's the SPL, the SPL divided by 2. So what's the minimum SPL required to demonstrate those as an individual structure?
Is that not right?
on that one.
Is
it
that
would
not
be
right?
1 millimeter.
Why?
Because you get 2 divided by 1, and it would be able to fit in between the 2, so it would demonstrate.
Is it not 0.1? It's not?
I'm sorry.
So if you do 2 divided,
Yes,
Yeah,
you're right. Yeah.
you do 2 divided, wait, would you,
He wants you.
SPL divided by 2, so it would be 2 divided by 2.
Which is 1. 2 divided by 2.
2 multiplied by 2.
Multiply.
Multiply.
Yes, because what's the definition? What is how we demonstrate? What determines the actual resolution? You know by memory that. What determines the actual resolution?
SPL divided by 2.
SPL divided by 2.
SPL divided by 2. So if this is 2 millimeters, what's the SPL?
4.
4.
I don't understand why you multiply it.
Because
That is
this
already.
is
Oh, that
already
is
half
the
of the
SPL.
SPL.
Yeah.
Oh, you're talking about
This
the
is half of
problem.
the
I thought you were talking
SPL.
about general.
Okay.
Yeah.
So therefore, the SPL, the minimum SPL will be
4.
Oh, you're talking about for this
Ah,
question.
he made us
I
work
don't
it
get it.
backwards.
You're talking about this.
aha.
He made us work it backwards.
Backwards, yes.
Why backwards?
Because he wanted to throw a loop.
You should write down the formula for them.
Yes, please.
Think about it.
He made us work it backwards. In our head, no less.
Yeah.
Wait,
That's already the SPL. You know how you have to
Once
solve for
again,
SPL?
once again, you write down.
Can you say the whole question?
If 2 millimeters is the separation between these two structures, if 2 millimeters is the separation between these two structures, and they are parallel to the sound beam. What's the minimum SPL required to demonstrate those as a separate structure?
Jessica, the SPL is axial resolution over 2, right? Right?
No, the
No,
axial
SPL
resolution
It's
is divided.
SPL over 2, right?
Yes.
I
Yes,
wasn't, I always
divided
thought
by
he
2.
said in general, what's the lowest SPL? I didn't know he meant for that question. So I was like,
It
oh,
is
point
for
what?
that
Oh, okay, so
question.
you get it.
Millimeters.
Is
I
that
mean, I
for that
haven't thought about
question?
it yet,
Oh,
because
okay.
I was thinking you said,
You were right. Is that, how many in your head? If these two structures are 2 millimeters apart, they are parallel to the sound beam. What is the SPL necessary to? It goes again by that definition. If I ask you, what's the axial resolution? How you calculate the axial resolution?
Yes.
SPL divided by 2. So that means this distance is already half of the SPL,
This is the formula, right?
That's not the formula, right? Well, what you can use
right?
is this, which is the 2.
So
Yeah,
what you
so
mean
it's
it's already sold?
he gave us this.
When you already have half of the
axial
question,
resolution.
half of the SPL.
Yes. Because we can
That
see
means
it. See it.
this is half of the
We
SPL.
have to work it backwards. What was the original number that
He gave us the axial.
got asked for the next month?
So if you
Yes.
write it down like the formula, and then it would be like 2 times.
So what's the SPL?
This is the
Look guys, look,
Oh, it's rearranging the formula.
Let me see.
look
It's
guys.
like axial.
So the axial is 2, and then it equals SPL divided by
SPL
7.
equals axial times 2.
Oh, I know about.
Yeah, you have
Okay, that's why,
It's the wording that I think.
well, that is what you guys have to master.
Yeah.
These formulas, this thing is not just for you to pass the board. You have to be able to apply. These questions are kind of apply questions. You're just trying to, anything that fits to your formula and the way how it's supposed to be asked. No. No.
Okay, so like, let's talk about what you said, like in the question. You said like the minimum SPL, so
Yeah, the minimum SPL.
to see 2 separate structures. So when you're in axial, you're not gonna see two separate structures, you're only gonna see.
Axial you will.
If you have a good axial resolution, you will see 2 separate structures. If you don't have a good axial resolution, if your SPL say was, okay. If your SPL was, instead of to be 4, was 6. If your SPL was 6 millimeters. Could you demonstrate this as an individual structure?
No, because they're 2
All
separate
right.
apart,
Because-
right?
Because it would end up being 3,
You would
and
have
they're
to.
2 millimeters apart. Yes.
3 will cover these 2 structures.
Correct.
And will be demonstrated like this.
Correct.
So we would be missing, okay,
Exactly.
okay,
You got it?
yeah.
Okay, that is also to think about, since the SPL is the wavelength, so what frequency is best to demonstrate 2 small structures, 2 structures that are separated by a small distance in the axial, in the longitudinal direction? Which frequency will be better? I have one answer. It has to be 50-50. A low frequency or a high frequency? Which one is? I already have a low. Who goes by high?
I'm gonna say
What was the question?
I'll take that.
Which frequency would be best
Yeah.
to demonstrate the axial resolution? Which frequency will have a best axial resolution? Higher or lower?
Hi.
High.
Why? If you said wavelength I'm applying the
Okay,
formula.
how you calculate the wavelength?
C over F.
C over F.
C over F, which will give you better frequency, better axial resolution.
So if high frequency is gonna give me a smaller wavelength.
It's able to fit in between smaller
Able
spaces
to fit between tiny spaces.
to see
If
different
you got a
things.
bigger wavelength, it will not be able to fit in smaller spaces.
And it'll show
Low
one
frequency
big
has
unit.
this big, but the two structures are this small. Low frequency will not fit here. So which frequency?
High frequency.
Frequency. Don't fight with me for that.
No, heck no.
Don't get frustrated. Just think about what is how I calculate this. Okay, based on that, you do your errors. So, rather to say high or low frequency, they can change that for something that we already know. Thick crystal or thin crystal. Which one will give you better axial resolution?
Thick crystal.
Thick.
A thick crystal.
I don't know. Wait, I get confused of that because of.
Because there's two rules.
Yeah.
We're talking about natural,
Okay,
right?
but when
So
you
naturally-
say when you say non-focused, that's natural characteristic.
Correct. Is that what we're talking about right now?
Is that is that the question you're asking us?
No.
Oh, you're,
That would
okay.
already be the.
In general frequency.
Okay, in general.
In
Okay.
general,
All
okay.
In general,
All right, thin crystal.
Ultrasound.
In ultrasound,
yes.
okay.
Which crystal will have higher frequency or lower frequency? The thin or the thick?
The thin,
The thin, so that's the
Yeah.
answer.
yeah.
Right to ask you, say, which frequency, the high or the low, they can say, which crystal will give you better axial resolution?
Thin.
The thin,
It's thin.
So you're saying the
frequency.
crystal,
yeah, the high frequency.
it's just the same as a frequency question.
Yeah.
Yes.
Yeah,
Specify which type of crystal we're talking about, that's all.
yeah.
You guys confuse the natural focusing characteristics.
Yeah, because it's
That's
like
why
a
you're
recip-
confused.
it's almost a reciprocal of what we learned from initially, so yeah.
All right, I
Try to
have
keep it
to
straight.
meet somebody at 10:30. Somebody has to remind me before I
Tell
get
them that
late
you-
again.
tell them-
Yesterday I got late to a meeting. So this one, you got this, right? This will be affected by the distance.
The depth, yeah.
Another way to say is, if I change the PRT from smaller to larger, deeper distance, larger PRP. How this affect the duty factor and how this affect the PRF.
Inverse.
All are related questions, right? All right. So, once again, usually 99% of the time they will ask you how to find the PRF, and they will give you the distance, right? And that's it. You already have the other data. What's the PRF for 11 centimeters deep? 11 centimeters field of view. First thing you do is calculate the PRP. You should know how to calculate the PRP.
I do 13. Yeah, that's what she's. Well, 143 right.
Was it times 11? He said 11. Yeah. Yeah.
What is that?
143 microseconds. Convert to milliseconds.
What is this?
7.
What is?
Well, no, it's, I don't know. I didn't want to divide by 143.
So it's 6.9.
You can do 1 divided by 143, but it has to be microseconds here.
Right.
Okay? What is this?
That's 6.9
6.99.
kilohertz.
6.9?
9. Yeah.
6.99, that's what I got, so.
Yeah.
I rounded it to 7.
0.6,
No. 6.9.
oh,
Yeah.
6.9.
Yes,
Because we are dividing by
Yeah.
point. Okay.
Does that make sense?
6.9 kilohertz. 6.999?
Only two nines. 6.993.
So you did all this right. All you
We can say 7.
Isn't it
7?
milliseconds?
I do it by milliseconds.
Because we're trying to find PRF, right?
Yeah.
So it's milliseconds?
PRF,
Frequency, hertz.
that's why I said always work with your units.
Oh, did I write this down wrong?
Even before I
PRF is
knew
number
this
closest
result,
to
6.99, whatever it is, I rounded up to 7. Even before I put this number, I already knew what the unit will be. That's why I recommend you to always, when you work, put your units. So what's the reciprocal to this?
Kilohertz.
Oh, yeah.
Kilohertz.
I guess I think I wrote this down wrong. Did I write this down wrong? Is this supposed to be PRF?
So whenever I have PRF, I always have to answer in the range of
I don't know why
kilos.
I did that twice. Okay. That's
Yes.
right.
In the range, like I said, what determines this kilohertz? Because the average human body size or the depth that you will use. We would not say field of view of 200 centimeters. We would never say that. If we go that distance, probably will be ended up being in hertz. All right, what about a similar problem? You will do this and you're wrong.
FP,
Well, I can say FPS.
frame rate.
Frame rate, very good. Don't forget.
I'll try that.
.00000. Give me a whole number. Yeah, you can do that too. No.
Why does that sound different?
Yeah. Yeah. Okay.
So what do we do?
10 centimeters, but
Microseconds?
but
per-
here it's, you need to cancel out this. Here you need something else. Point 13 watt. 13 watt. You remember how I did the other problem?
Over
How
centimeters?
you got it wrong? All right. First you have to find a frame time, right?
Yeah.
Some of you are trying to simplify or trying to abbreviate at 13 microseconds per centimeter. But remember, you have to put the right unit. Put the unit first. Write down all your units so you will not get confused. So, let's start. 13 microseconds
Over
per
centimeters.
centimeter.
That's what we,
The depth,
10 centimeters.
10 centimeters,
Lines,
100 lines, right?
yeah.
So you cancel out this, right? So you ended up with 1 0 here and 2 zeros on the other side.